Hey coders, welcome to the channel. So in the previous video we have seen that what is binary search and how it works, and today we are going to implement that in Python. So without wasting any more time, let's get started. So before writing the code we must have some basic knowledge that what logic does the binary search uses. So you can watch this part of the video in 1.5x speed, or you can skip this part of the video and watch directly to this part. So now we have this list, and let's see that how the binary search implementation will look like. So let's say that we have to find the element 19 from this list. So what we will do is that we will define some variables, and the first variable will be u, and the second variable will be l, and the third variable will be I. So the value of this L will be 0 initially, and the value of this U will be the length of this list minus 1. So let's say small l minus 1. So this will be the value of U. And what will be the value of this I? So the value of this I will be U plus L divided by 2. So this will be the value of I, and let me tell you what this means. So this L means the first element of this list, and this U means the last element of this list. And what this I means, so let's calculate the value of I. So U plus L is 7, and 7 divided by 2 will give us 3, and this 15 is at the index 3 of this list. So this will be the I position of this list. So in binary search, as we know, we search for the first element and see that if that element is equal to the number that we are searching of, and 15 is not equal to 19. And what we know is that 19 is greater than 15, and in the case that we got our element that we are searching of is greater than the element that we have found, then in that case what we will do, we will change the value of this I. So the not that I, it's L. So L will be I plus 1. So I is at 15, so L will be at the 19. So let's erase that L out. So if the value of L changes, then the value of I is also dependent on L. So the value of I will also change. So now let's calculate the new value of I. So now the U is the same, which is 7, and the L has changed from 0 to 3. So 3 plus 7 is 10, and 10 divided by 2 is 5. So this I must be at the 5th position of this list, or at the 5th index of this list, and the 5th index is this 21. So this will be I here, and let me erase out the order I. So now we will do the same process again. We will check that if the element at the I position of the list is equal to the element that we are searching of, and 21 is not equal to 19. So now what we know, that 19 is smaller than this element. And now when we know that the element that we are searching of is smaller than the element that we have got, which is 21, so in that case we will change the value of this U. So the value of this U will be U equals I minus 1. So I is at 21, so this U will be at this 19. So let's write U here, and let's erase that U out. So the value of U will be at 19, and L will also be at 19. So the value of I will also change, and the value of I will also get 19. So let's erase that out. And now we will again check for the element at the L position, not L, it's I, at the I position, and at the I position of the list it is 19, and we got our element which is 19. So the implementation of binary search will look like this. And now let's write some code and make up our binary search function. So first we will make our list on which we will search for a value. So let me write list equals list range 100. So what this statement is doing is this statement is generating a list of numbers starting from 0 to 99. So this list variable has a list which has 100 elements starting from 0 to 99. So now let's make up our binary search function. So let's keep the name simple bin, and this function will take two arguments, and the first argument will be the list in which we will search for the information, and the second will be the information itself. So now let's define this function. So as we have seen, we have to define three variables: L equals 0, U equals length of list -1. So this is the length function, and this length function returns the length of a object, or let's say list, array, anything. And the third variable was I, and I is equals to U plus L divided by 2. So we are using floor division here. And now we will add a loop here while true, not true. We will add a loop while U is greater than or equal to L. So what this means, in the case that the lower bound will be greater than the upper bound, then we will break out of this loop. So now let's write some code under this loop, and we have this defined. So there will be three cases. The first case will be if I, not I list, at the index I will be equal to the element that we are searching of. So in that case, what we will do is we will return the index number of the element that we are searching of. So we will return I, and and there will be the second case, elif, and the second case would be if list at the index position I is greater than the element that we are searching. So our element is smaller, so in that case we will change the upper bound, and the upper bound will be uh, I minus 1, and which we have discussed before. And after that we will also add a statement continue, and what this statement continue does is it will send the executor again to the starting of this while loop with these updated value, and we have to also update this I. Wait, I will be, let's copy this. So what we are doing, adding this statement. So this statement is refreshing the value of I, as we have changed the value of U, and the value of I is dependent on U. So that's why we are refreshing the value of this I, and this continue will make the bring the executor to the starting of this loop. And there will one more case, and that case will be list at the index position I will be smaller than the element that we are searching of, means our element is greater. And we have also seen that in the case that our element is greater, then we will change the lower bound. So the lower bound will be I plus 1, and we have seen that. And we will again refresh the value of I, and add continuous statement. So let's copy and paste that here. So yeah, our this binary search method is completed, and one more statement that we have to add is return false, and this statement will only execute after this while loop is completed, and this while loop will only complete if the element is not existed in that list, and if the element is existed in that list, then this method will return I and will stop functioning. And so this is our binary search method. So let's call this method. So let's say bin, and let's pass our list which we have created, and let's say that we have to search for 55, and 55 must be in the list as 55 is between 0 and 99, and we have created the list starting from 0 to 99. So let's run this code. We forget to print this, so let's add a print statement here, and now let's run the code, and it says 55, which is correct. So this 55 is at the index 55, and now let's try for an element which is not existed in this list. So let's say 120 130. So 130 is bigger than 99, and which will not be in our list. So now let's run this code, and yeah, it shows false, means our element is not in the list. So binary search algorithm is working. If you find today's video helpful, then don't forget to like the video, and to get notified for this kind of interesting content regularly, subscribe to the channel, and thank you for watching the video.